Oh, hello there. I was just going to talk about function overloading. Oh, what's that? You want to know function overloading too? Well, what a funny coincidence, but welcome to the right video. So, let us begin. What is function overloading? Well, before I tell you that, let's talk a little bit about functions and kind of build up to that, shall we? So, let's go ahead and just write a simple function, something that you would have seen in a previous programming class. So let's say we write something like void foo int a, and then this function, let's just say it prints out the value of a, and include IOStream using namespace ntd blah blah blah, right? We all know that cool stuff. Okay, so you got yourself a function. And it's a really cool function, your boss is like super happy with you that that you just did a function that prints out A, and like that's exactly what they wanted until they want more, right? Because that's the classical story of programming, is that you deliver something and they're like, oh, it's amazing, but like, wouldn't it be great if it also did, and then there's 10 more hours of work usually, right? Well, here it might not be 10 more hours of work, but let's say that your boss all of a sudden says, this function is really cool, but like, hey, can we get one that works with a double or like a float? And you're like, yeah, actually, this actually might work with a float and a double. Kinda, as long as they're full numbers, right? So like, if let's say that we're calling this function and we are passing in an integer, then this is cool. This will work out fine. But if instead of an integer, they're passing in like a float. Sorry, I'm getting used to using markers again after 2 years. But yeah, so let's say that instead of passing in like a double, instead of passing an integer, they're passing in like a double, right? In fact, small tip here, if you're hard coding numbers like this in C++ with decimals, these are automatically set to be doubles. If you actually were intending to be a float, you typically have to put an F in front of it. This can play kind of tricky roles if you're comparing two numbers. So like, let's say you actually have a float in a variable and you're comparing it with something like this. So like, ignore this for a second, but like if you were saying 5.22 is equal to like some variable t, and that t was a float, you're comparing a float and a double, and that can potentially, even if that float t had 5.2 in it, these things might not turn out to be equal, because it turns out that this here is actually a double. That is then coerced. Oh, well, float t. I forgot the t actually. There we go. So it's being coerced into a float. And now that it's actually a float, it's being compared with a double. And because of the double precision accuracy versus the float precision accuracy, these things may not be equal. It's unlikely, but it's possible. This is how accidents happen when your calculations are off by a tiny little bit and your Mars Explorer thing crashes or something, right? So yeah, just slightly off topic, but then again, it is kind of the beginning of the semester, so it's always good to refresh these kind of things. Okay, well, let's go back to our boss here. Our boss, he now wants something like this to work. And you're like, well, yes, but no, like this will work, but what's gonna happen? Well, if this is the only function foo that you have, it has an integer parameter, right? So what is happening here, well, integer argument, this is the parameter and that's the argument. So what's going to end up happening is this is going to be sort of forced into an integer. So like, you can think of like this little bucket holds an integer, right? And you're trying to throw in like this garbage can, which is a double. And so, when you're throwing it in there, things are going to get kind of tight. So it's going to look like this. The back's all going to be like overflowing and whatnot. Maybe a bad example, but ultimately what's going to happen is, suspense, it's going to become an integer, right? So it's still going to print out 5, which probably is not what your boss wanted, but that's what you're going to deliver the first time so you can get paid that day and still get paid for more work, Don't ever deliver the final product in the first go, otherwise you get fired because you have nothing else for you to do. No, I'm just kidding. But ultimately, this works, but not really what you wanted. What you want is a 5.2 to be printed out. So you're like, okay, what can I do? Well, in theory, what I would do actually is I would just make this a double, right? And so now, this will work for integers and doubles, because for double, it's going to print out 5.2, and then for the integer, it's going to coerce it into a double, but you don't really lose accuracy there. So in theory, you're pretty much set. Okay, cool. So, I mean, you have to change the original function, but you kind of worked around it. But then your boss is like, okay, cool, you know what, but like, you know, this is awesome, but like, you know what would be awesome? If you could use characters too. And you're like, oh boy, here we go. So like, he's like, now I want you to be able to pass in there. Something like that. And you're like, all right, very cool, boss, very cool. If I do this right now, I'm actually not 100% sure what's going to happen. I'd have to test it on the interpreter, or compiler, I guess. Plus, it's compiler language, not Python. If you want to learn Python, you're in the wrong class. You could be taking 621, or I guess CS 140. But yeah, so in this case, like, what's probably going to end up happening if it compiles and runs is that it's going to get forced into a double. So like whatever the ASCII equivalent of C is, which is like somewhere around like 80 something. You know, in fact, here I can very quickly Google that. So ASCII table. Oh, here's a, let's test if this is going to work. Oh, yeah, work, kind of, sort of. I made it so you can see the screen if I ever need to share it. But yeah, so there's the ASCII table. I know it's really tiny, but trust me when I say that the letter C lowercase is 99. So I was close. What is 83, by the way? Since that's the one, that was my initial guess. 83 was like S, capital S. Well, you know, if I just said like that, then I could get away with it, right? And say like, oh yeah, you know the actual ASCII table by memory. Yeah, no. Why would I? So anyways, because we're saying that C is going to be 99, then my guess, and this is just a guess, I could run it in code, but like, how about you do that, you know? Gets you a little bit active and gets you off the just watching the video, right? So you go and try it out and leave a comment below if it works and what the output is. But yeah, what I think is going to happen is it gets forced into a double by like 99, and then you get a 99 printed out. That's like best case scenario. Worst case scenario is that the program doesn't compile. Now, why wouldn't it compile? Because, you know, C++ is flexible. It lets you coerce things that it can coerce, but sometimes it draws the line. In fact, if it doesn't draw the line there, let me tell you where it's going to definitely draw the line. Let's say your boss is like, you know, one character worked because somehow that really compiled and worked. And so they're like, well, what about 2 characters? So you're like a hi. Well, 2 characters, you can't really put 2 characters together unless it was multiple parameters, but you could do a string, right? So this is more of a string. So now you got a string in there, and now it's like, okay, that is definitely not going to work. I could almost bet on it, but I'm not a fan of gambling. So maybe I live in the wrong city. But yeah, so yeah, I don't think that one's going to work. It's going to definitely give you an error and say that it cannot find the right function. And in fact, you might start to think, why does it say cannot find the right function? Why can't it just say like the function's not found at all? Well, in fact, the error is actually going to go further than that. It's going to tell you that it found a function with the right name, but that the arguments don't match. And that's because you're trying to make it into a double when it's a string, and there isn't really any way to convert that. Now, later on in the semester, we're going to learn a lot of cool things like templates and all these operator overloading fanciness and whatnot. So what I'm about to show you today is just one of the ways to solve this issue, but not necessarily the best way or the most efficient, but there are some scenarios where this is the best way to do it. Okay? So that's the disclaimer. So what would you do? Well, you could just write a brand new function and call it like bar. So I could say like, let me just go ahead and write a function called bar that handles strings. So let's do bar handles a string, a, and then blah, blah, blah. The rest of the cout statement, right? Cout a, and you're good to go, right? So you could do that. And it's okay, but your boss wants it to be called foo. And why? Well, because he wants, you know, like this, you're writing a library that other developers are using, and they want that ease of convenience that they know that this function name is going to work every single time. Now, is that asking a lot? I don't know. I mean, if you know C or if you know Python, you know that there are functions called print. Well, print in Python and in C is printf that like literally will handle everything you throw at them. Like they're like they're homies. They will print out whatever you want. So Yeah, so that is not asking too far. Like, that's not a far-fetched request. So you're stuck in a situation where like they really want it to be called foo. So what do you do? Well, what you do is this right here. You overload. We're gonna overload a function so that it can do more. So how are we gonna do that? We're actually gonna make another function like we do have it here. But we are actually gonna call it the same as the first one. So we're gonna call it foo. So we have now overloaded foo. End the video. Have a nice day. Well, maybe I should do more examples and explain to you a little bit more. So let's do that. Otherwise, I mean, that would have been great. 10 minutes lecture done for today, right? Can go on the rest or go to your next class. But no, let's do more examples and let's understand like what just happened, okay? So, function overloading is a very simple concept once you understand it, but the first time you hear it, it sounds kind of scary. So all it is that in C++, you can have more than one function definition for a function name. So in this case, we started out with foo, and it has a parameter double, and it has some code in it. And so if I try to write another foo function that had the exact same argument here, or parameter, like this one, I am using those back and forth, but there's technically the right one. I'm pretty bad at that. I guess arguments are these and parameters are these, when you're calling it. I think that's the official name, but that's okay. Don't worry about it. We're not testing you on that sort of stuff at this point because I don't even remember it. But yeah, so what I'm saying is like here, you have the function name, you have all the arguments / parameters, and then you have the body of the function, right? So what C++ compiler says is that you cannot have two functions that have the same name and the exact same parameters because basically it gets confused. It's like, which one do you mean to call? Like if I literally wrote two functions that said foo, even if I use like a different name of the parameter here or argument, like if I said like double B, it's still going to be like confused. And even if this code is different, like if the functions do some different things because it doesn't know which one you're calling. Like look at this function call right here. What is it going to do? Like what am I going to do here? Like am I going to call this one? Am I going to call this one? Or what am I going to do? Right? So ultimately, he gets confused. And it will be an error like that. It'll say that, you know, they're ambiguous. So ultimately, you can't do that. But what you can do is you can have the same function with either a different number of arguments or with different type of arguments if they have the same number. So like we had here, where this one's like a string. Now, you could also do an integer one. So like, that was the original one that we had, right? So let's just go ahead and kind of put that back in. A bunch of code. Well, I guess we don't want to make this confusing. So there you go. They all have the same C out A in them. I just don't want to have to write that. You know, if I was in the computer, I'd just copy paste. But here, it's like it takes time. So in this case, we have three functions, and they're okay because they have different type of parameter here. One of them is an integer, one of them is a double, and one of them is a string. And so depending on the function call, whether it's like one of these or these or these, it's going to basically send it to the right one. How does it know? Well, it's going to take whatever the type of the parameter is, and it's going to look in the list of functions to see which one's the closest. Okay? Now, what do I mean by closest? Well, ideally, it's an identical match. So, for example, this is a double, as I said. So if there is one that has a double, then it's like, well, I know that's the one that I got to call. In the case of something like this, it's kind of iffy again because it's like it's a car, and so that car needs to be coerced into an integer. That's more viable, and I'm pretty sure that will be okay. However, sending it to a double is kind of like further away from the coercion sort of world, or a string. It's like, huh? So it would also not get confused with that one. And similarly with this one, because it's a string, it can only have one choice that it can go to. But you can't confuse it. You can definitely confuse it, and you can get in trouble if you have scenarios where things are ambiguous. So, for example, let's say that what do I want to do here? Okay. Let's switch the int one to a car. So at this point, I'm just going to get rid of this body. You all know what's in there and them functions. So let's say that we make this one into a car. So now this one definitely is going to go there, and the string one's still okay, and the double one is definitely cool. So they're all very clean. But let's, instead of doing a double for this one, let's say that we're passing just an integer. This one's kind of tricky because the integer can be coerced into a double. It's still a sort of coercion happening, but like it just makes more sense to do that to a double than to a car, right? But at the same time, like the car kind of fits an integer because the car is just that ASCII table of integers. However, if if this number was bigger than I guess 128 or 256, 128, right? ASCII table, yeah, 128. If it was bigger than 128, then it would overflow if it was stored in the car. So it can start to get confusing, and you definitely want to code something like this where it just doesn't know. You would want to have an integer option here. But let's go further than that. So in addition to being able to have multiple function definitions, the same name, the same number of arguments, which is different type of arguments, you can also have functions with the same name but different number of arguments. So for example, we could do something like this. Okay, and then there's the rest of the code right there. So this will work too, and so that one's not going to call for any of these scenarios. But if instead of this one maybe we had like 5, 6, then it's definitely going to call that one, right? And so why would you do this? Well, this is again like your boss wants you to print more than one thing now. So you still want to keep the same function name because it's convenient, but you want it to be able to do more things. So like to the end user per se, well, not end user, but the coder who's doing the client code per se, they just know that this foo function handles everything you throw at it. Behind the scenes, you know that it's actually multiple foo functions, and each one's basically raising its hand whenever it's its turn to actually work. And this is cool. This is also not ambiguous, but the reason I give you this example, other than being able to see that you can do multiple parameters, a different number of parameters, is suppose that now I write another one. And here's the issue with the overloading. The code will compile, like when you overload stuff, and actually the code runs and everything, and you think the code is okay until you send it a function call that is like ambiguous, and then the code does not compile. And you're like, why does not compile now if all I did is a simple function call? Well, because you broke the code or you found an edge case that the developer didn't think about. So what do I have here? What I have here is the function foo. In one of them I have an integer and a double, and in the other one I have a double and an integer. So like, what would be a good case scenario of this? Well, let's do some function calls. Let's change some colors. I feel like I'm Bob Ross right now. That's kind of interesting. All right, so we got some sky blue and some pink. I can't think of something that's pink. Lip pink, I guess. All right. So we got some sky blue, and now we're going to apply some some lip pink. If I really was hardcore, I would like annotate that code by like an actual IDE, but that would take a lot of writing time. But yeah, so we have a function call, and this is legit because this one is like has an integer and a double, so it's obviously going to call. Little pause there so you can think ahead of time, but I'm pretty sure you got it. It's going to call that one, right? Cool. All right, let's do another one. Let's do that one. I know I haven't written semicolons, but just imagine they all have semicolons. They're all the friends and stuff. Like the happy chairs in Bob Ross, we got the happy semicolons. They always together with the dot and the comma, right? So here in this one, we know that it's going to call that one, right? So no confusion there. Actually, this is yellow, but it looks green here. So I guess, what is this then? Are they different? I guess they are. Kinda. Yeah, there's a slight difference in hue, but it's like very little. Okay, cool. So I only really have 3 colors. For a second, I thought I was a little bit colorblind. Okay, so no problems there. But like, I've been intentionally stalling because there's this one. This is the one that's going to be a problem. Who does that one call? Who are you going to call? Ghostbusters? I mean, who? Let's kind of look, let's go from top to bottom. It's definitely none of the first three because there's two parameters. So obviously if the parameter amount do not match, like argument count, it's gone. It doesn't work. So last two obviously are options that we can consider. So, okay, so let's kind of think about like how many coercions do we need to do for them to work. So if we try this one, we know that we have an integer here, which matches an integer here. So that's good. That's an exact match. So far so good. But then we got this double, and then we have an integer here. So that's going to have to be one coercion, right? We're going to have to go from integer 6 to a double 6. Okay, so that's one coercion. So that, I mean, if that was the only option, if that was like the function that we had, it would work, and they would just be coerced, and you'd be on your way. But there is another, that one. In this scenario, the double here is a coercion. So okay, so -1 per se of coercion work, I guess. But this is an exact match over here. So we have a scenario where we have a function call, and that function call could go either way, and they're both sort of like one distance away, because they both have one parameter that matches exactly, and they both have one parameter that does not match and needs to be coerced. But like, you know, if you're keeping track of points, you know, you could say this is like a +1 good, and then 0 here, or like -1, whatever you want to count it. So they're both kind of the same distance away. And I know for a fact that this will not compile, and it's going to be an error, and it's going to say that the function is ambiguous. Function call is ambiguous, and that is because it doesn't know. So this is another issue with operator overloading that you have to think about. If you don't have matching cases for any like possibility, because I mean, think about it. How many data types you have built in C++? You have integers, floats, doubles. Strings are technically not built in, but I'm just going to throw them in because you can use them pretty easily. So integers, floats, doubles, integer, floats, doubles, strings, cars. Well, I guess shorts, longs, kind of, yeah. What else do we have? Booleans, I guess, I think, yeah. C doesn't have them, but I think C++ does have Booleans. So, okay, that's good enough right now. So what are we at here? 6, 7, 8, right? So we 8 data types, right? That you have to consider if you have one parameter. But you have 2 parameters. How many combinations do you have to do there? Well, you know, basically 8 times 8 basically would be 64. Do you have to consider all of them? Yeah. Well, I mean, there might be some flips. I don't know if it's a permutation or combination problem. Ask your math teachers those things. But ultimately, it's going to be a ton of them, okay? And so you can think about, like, now if you have 10 parameters, that is going to be a massive amount of numbers. So there's just no way that you're going to have a single line of code for each of these, right? Like, not a line of code, but a single function for each of these, which could be multiple lines of code. So you are going to have to make some compromises and do some coercions, right? But you have to think about smart, how to do the ones that you need without doing the ones you don't need. But if you do too few, then you run into this kind of scenarios. So that's the big sort of danger with function overloading. So with great power comes great responsibility. And so there you go. So that's all I got to say about that. What else do I want to say now? Like, really, I don't really have anything else that I can say about function overloading off the top of my head. When we learn about what templates are, you will see that it's a lot like function overloading, but like 10 times cooler. But with the 10 times cooler part, it also becomes a little bit more complicated. So I think function overloading definitely has its place in your code. There are other things you can do that kind of do the same thing, but they might be overkill or unnecessarily make code harder. So definitely use it, like it. And it's a first example, actually, of what I would consider to be compile time polymorphism. Now, that's a really fancy word that you're going to hear a couple of times throughout the semester. So let me go ahead and spell it out for you since it's the first time you hear it. So compile time polymorphism. I wonder if you can hear the squeaking sound as I write this. So I'm not going to really define this term for a while, but we are going to start talking about object-oriented programming in classes, and this is one of the cornerstones of that. Like, you know, like if you think of like the pi4 symbol, one of those corners is like polymorphism, and then, you know, inheritance, and What would be the third one for? Well, just encapsulation. I don't know. But yeah, I'll review that before the next video, I guess. Actually, I might have it here. What is the other one? Data abstraction? Kind of. I don't know. Abstraction. Yeah, abstraction. So we have abstraction, encapsulation, and polymorphism. That is sort of the Triforce symbol of object-oriented programming. Okay? But I'll continue that on the next video, so I'll let it be for now. So polymorphism it stands for, if you know your roots and everything. Poly is multiple, and morphism or morph is shapes. So multiple shapes. And what it's saying is that your code can take multiple shapes, so it can do a lot more than what it looks like per se. You know, a function. If you just write one function, it does one thing, right? But now I'm saying you have one function that can do multiple things, so that's your polymorphism. And it's compile time because this is all happening at compile time in comparison to runtime. So runtime is the thing that we're going to explore a lot when it comes to dynamic memory allocation and virtual functions and all these cool things. So for now, don't worry too much about that. Don't get scared. These are all really cool things that we will learn, and they're going to make your life easier, not harder. The point of learning to program is not to make your life harder. It's actually to make your life easier, right? You don't want to repeat things that you are doing in life. You want to be able to code something so that it runs, and you never have to worry about it again until it's a bug and it crashes, right? So sometimes we kind of lose sort of that sight of what our goal is, that to make our lives easier, not harder. So all these things you're learning in programming, they're supposed to make your life easier. So function overloading, make your life easier, or at least make your boss's life easier, or the end user's life easier, right? So yeah, there's a little bit of that too. But yeah, that's your polymorphism there, and it's the first time you see it. But again, we're going to explore this term for a long time throughout the semester. And next time, when I do start talking about object-oriented programming, I will explore more about what this little triforce of polymorphism, abstraction, and encapsulation are. Okay, but going back to function overloading, that's really all there's to it. It's a very simple concept. The only thing you have to be careful about is to make sure things are not ambiguous. Perhaps at some point, maybe once in the computer, I'll write a couple of coding examples, but you're also welcome to watch previous semesters where I have recorded lectures on like the first few lectures of 202, because I was doing those on the computer, and I did run some examples so you can get to see. I encourage you at home, as you're watching these lectures, to try to code some of these examples and see those errors firsthand, because like then you will, it's like, you know, they say, you know, why do we fail? So that we can learn to stand up, that kind of thing. You actually want the code to give you an error now so that you can start learning the errors related to things like function overloading. So that if you see that error when you're coding your assignments or just a project in general, then you know what that error is and how to fix it. Obviously, if you don't know how to fix an error and you've never seen it before, best thing to do is copy and paste it into Google and find Stack Overflow or someone who says, you know, what that error is, and take it with a grain of salt and explore, but you'll pretty surely find how to solve it. So ultimately, it's important that you guys follow along and try to code some of these things and you see those errors. So even if I'm not showing you what the errors looks like, try them out, see them, and embrace them, okay? Cool. Well, that's all I have for today. It's a rather short video, but I'm going to go ahead and do the operator overloading, object-oriented programming one next. So stay tuned for that. Thank you for watching, and if you're watching this on YouTube, don't forget to like, comment, and subscribe, I guess.